Today is October 5th, and we are starting a new unit called Pythagorean theorem and its converse. And the first thing we will be talking about is in a right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. This is known as Pythagorean theorem. Also stated, we know it as a squared plus b squared equals c squared. Now, when they talk about legs and hypotenuse, the first thing you need to know is how to identify your hypotenuse. You simply go from your right angle and draw an arrow, and it points where your hypotenuse is. The other two sides obviously will be your legs. Now, on the a squared plus b squared equals c squared, the c is your hypotenuse, and the a and b are your other two legs. Now, this is a great theorem, and it's a great way to memorize the Pythagorean theorem, but we don't only find c squared or b squared. We usually want to find a leg or a hypotenuse or the other leg. And that means we want to find a or b or c. So we've got to take the square roots off of those. So if I was trying to find c itself, I would just take the square root of a squared plus b squared. If I was trying to find a, it's a little different here. I'd have to take the square root of the hypotenuse squared minus the other leg squared. So c squared minus b squared. And b, same thing, square root of my hypotenuse squared, c squared, minus the other leg, a squared. Now, how do you remember when to add or when to subtract when you're doing Pythagorean theorem? It's really easy. If they give you c, you subtract. If you don't have c, you add. That's the easy way to remember this. So let's practice Pythagorean theorem a little bit. Okay, so let's look at number 1. My c, my right angle is right here. So this is c that they're wanting. So to find c, I have to use square root of the other two sides added together squared. So 6 squared plus 10 squared. This would give you the square root of 136. Now, 136 is not a perfect square. If I were to put it in the calculator, I would find out that it is not a perfect square. So, I need to simplify this radical. I do not want decimals on this particular unit. We don't want decimals, we want simplified radicals. So, I would simply ask myself I'd start at the lowest perfect square other than 1, which is 4. And I'd say, is this divisible by 4? Yes, it is. So I take it out. 4 times square root of 34. Okay. Now the square root of 4 is 2. So 2 square root of 34. Now let's move on to number 2. Again, they're wanting c. So it would be the square root of 5 squared plus 14 squared. That gives you the square root of 221. 221 is not divisible by any perfect square, so you would just be left with that. Okay, so I'm looking, and square root of 221 is not divisible by any perfect square, so it stays just square root of 221. It's already simplified enough. So let's look at number 3. Again, we're looking for c, so it's just square root of 4 squared plus 3 squared, which ends up being square root of 25, which is 5. Okay? So these were the easier ones where you're finding the hypotenuse. But they're not always going to be this nice to you. Sometimes they're going to change it up, and they're going to give you the hypotenuse and want one of the legs instead. So in this instance, I'm given c, so I'm going to subtract to find, let's call this side A that we're looking for. It doesn't matter if I use A or B, it's the same process. c squared, 12 squared minus 8 squared. That's 144 minus 64, so that'd be the square root of 80. So this is where you start thinking, are there any perfect squares that 80 is divisible by? Well, yeah, 80 is divisible by 4, right? So that turns into square root of 4 times square root of 20. Then you go, well, wait a minute, 20 is divisible by 4, so that's another square root of 4 I can take out, and now give me square root of 5 left over. Well, square root of 4 is 2, square root of 4 is 2, 2 times 2 is 4, and then don't forget your square root of 5. It's still part of this whole fine thing, and you have solved this triangle. Okay? Let's look at the next one. Well, let's say we're looking for B this time. Doesn't matter if you use A or B on these. So 9 squared minus 2 squared. That'd be 81 minus 4, which gives you square root of 77. There are no perfect squares that go evenly into 77, so that one is now done. Alright, the last one on the triangles that we're going to do before we move on is this one. Again, I'm given C, so square root of C squared, 74 squared, minus 22 squared. And that is, let me put this in my calculator because I can't do this in my head either, 4,992. So that's the square root. Please don't forget your square root. 4992. Now, if you look, that's divisible by 4. It'll be 1, 2, 1,248. Now we'd say, is 1248 divisible by 4? Yes, it is. So take out another 4. That becomes 312. Okay. But wait a minute. Uh-oh. It again is divisible by 4. So here we go. And then you're left with 78. Okay. So these are all 2. So 2 times 2 times 2 is 8. Square root of 78. And you're done. Now, so far we've only been finding sides, but Pythagorean theorem can also help you to classify a triangle when you're given the side lengths. For instance, if a squared plus b squared equals c squared, then you have a right triangle. If a squared plus b squared is less than c squared, then it's obtuse. And if a squared plus b squared ends up being bigger than c squared, then you have an acute triangle. This is how you can figure that out using just the side lengths of the triangle. Let's give it a try. We're going to classify these following triangles if possible. Very important, those last two words, if possible. That means you need to figure out if it can make a triangle or not. So let's look at this first set of numbers, 1, 2, and 3. Is 1 plus 2 greater than 3? Nope. So this isn't even a triangle. So we can't do this. We can't classify it if it's not a triangle. So we just write not a triangle. Now, 3, 4, and 5, 3 plus 4 is definitely greater than 5, so I do have a triangle. So how do I figure out which one's my C? It's really easy. C is your longest side, so 5 here is my C. So I do 3 squared plus 4 squared, and I compare it to 5 squared. This is 25, and this is 25, so they're equal, so this is a right triangle. Now, 6, 7, and 8, again, does make a triangle. So I compare 6 squared plus 7 squared to 8 squared. 8 squared is 64, and this is 85. 6 squared plus 7 squared, so it's bigger, so it's a cute little triangle. Okay, so I'm thinking you're getting the gist of this now. So that in a nutshell is the notes for today. I hope you enjoyed the recording. If you have any questions, please feel free to come in for tutoring.